Hello everyone. Today we are going to learn 9.2 estimating population proportions. So we talked about a little bit how to make a confidence interval last time, right? So we have objective here, learning objective. And then let's talk about more about the population proportions for this section. Okay, first of all, uh, let me write down estimating, right? So we have a point estimate. So we have a point estimate. That is the same as a sample proportion, right? Sample proportion. So that is p hat, which is x over n, right? So x is number of successes over number of sample size, right? Yeah. Okay. Uh, then we have a confidence, no, interval estimate, right? So interval estimate. So we are using point estimate because we have one single number. So if we are using formula x over n, that is the number of success over number of sample size, we get the decimal, right? So one single number. That's why they said the point estimate. But then we have interval estimate. So like interval notation from the algebra course, right? So like this, right? Then we are using the left side is lower limit and right side of number is upper limit, right? Limit. Yeah. Other textbook indicate that lower bound and upper bound. Okay. So what do we estimate, right? So basically we estimate PL for population P, right? Estimate P. And also we have another one, right? So we have X bar estimate for the mu, which is population mean, right? Okay, population proportion. Yeah, a little bit messy. All right, then let's go back to the confidence interval. So we have in the middle, we say that that's the p hat, and then left side from p hat we take out margin of error. We had p hat and plus margin of error, right? So we talked about this one in the previous course, I mean the previous section, right? Okay, so that is the lower limit, upper limit. Make sense? Okay, now margin of error. So, noise. Sorry about that. So we want to make more confident, right? So we cannot say that that is accuracy, about the accuracy, right? So we want to make margin of error. So make a little bit wider so that we can say that, oh, this is a 90% confidence. Oh, this is a 95 confident. Oh, this is a 99 confident. It depends on the margin of error, right? Not depends on the margin of error. If a margin of error bigger, then we get wider interval. If we have a small margin of error, narrower interval, right? We talk about that. And we talk about the, again, the last section, not the last course, last section about sample size. So if we have a smaller sample size, that means we have large of the sample size leads, small sample size leads, large marginal error, right? And then large sample size leads smaller marginal error because we don't need that much because more sample size, we get more accuracy, right? Make sense? Okay. Whew. Last course. I mean the last section. Okay. Now, then what is marginal error? So we have a marginal error. We have z sub alpha over 2. So we called this one is critical value. Z critical value. Z critical value. So it can be Z score. So all Z critical value, we call the Z score, but not all Z score is critical value. Yeah. This is a special Z score. Make sense? Think special Z score. All right. Now we have this formula, right? So this formula we called standard error. Standard error. Okay, so we knew this one before from the sample proportion of sampling distribution. So we had a standard deviation. Standard deviation, let me write down. Standard deviation of sample proportion of sampling distribution. That is sigma sub p hat, right? Equal to, we had square root p 1 minus p over n. Yeah. But then if we don't know about the p, which is population proportion, we can use p hat. So we have a p hat, right? And then 1 minus p hat over n. So when p unknown, I'm sorry, p unknown. In that case, p unknown. Yeah, and then we called this one is a standard error, not the standard deviation. All right, so what is a standard error? So I wrote down here. So standard error is how much the sample statistic. So what was the sample statistic? Sample statistic? Yeah, it's a sample mean, sample standard deviation, sample mean. I did sample mean, right? Sample mean, sample standard deviation, sample proportion, right? So, like we can use the symbol. So, sample mean, which is X bar, and sample proportion p hat, right? Yeah. So we don't normally talk about the standard deviation. Okay, so how much the sample statistic varies from sample to sample. Okay. And then I wrote down, think how spread out sample statistic, which is X bar, p hat, R, right? Then I wrote down what's the standard deviation. Standard deviation we can compare with the standard error, right? So standard deviation, how spread out individual data points are. Yeah. Can you see that? This is a sample to sample. This is individual data points. Clear? What's the difference between standard deviation and standard error? Make sense? So basically, margin of error for the formula, we have z critical value times standard error. All right. So standard error, that formula come from standard deviation for sample proportion of sampling distribution. We can just using p hat instead of p, right? All right. Let's take a look. We want to find out what is z sub alpha over 2, which is z critical value. All right? Okay. So they say that the value of z sub alpha over 2, so we read alpha, right? So alpha. It's in Greek letter, Greek alphabet. So alpha. All right. So alpha over 2 is the z-score value of the standard normal variable z that has area alpha over 2 in the right tail. Right tail. Talk about the right tail, okay? All right. So let's do this one. Let me copy this one. And then let's work the example. All right, so let's take a look. We have this example, finding alpha over 2, and then the z-score. All right, so we have the first one, 90% confidence interval, right? So alpha will be 100% minus 90%, which is 10%, right? Which is 0.1. Okay, then uh, alpha over 2. So alpha over 2, which is 0.1 over 2, that will be 0.05, right? So there will be z sub 0.05, and then 0.05 means right tail, the area of right tail, right? Now, how do we get the z-score? We can use the secant. All right, so let me take a picture and then go over normal curve. Yeah. Okay, let us do that. I don't touch anything there. And share screen. And then make a, and then stop here. All right, so open secant. All right, so let's go to stack calculator normal, right? And let me highlight this one. Stack calculator normal. Yeah, click that. All right. And let's see. What we are doing, we want to find the z-score, right? All right, so when we find the z-score, then this is z, right? And z-score has mean equal to 0, and standard deviation is the 1, right? Just keep that way, mean equal to 0, standard deviation is the 1, right? Then right tail, we're gonna use greater than or equal to, right? And then we want to know about the z-score, so make empty there. And then what is right area of right tail? There is 0 0.05, 0.05, yeah? So compute. Okay, so we have a 1.6448, right? So normally we have z-score 2 decimal places, but then sometimes we have special z-score is 3 standard. No, so, I'm sorry. Oh my gosh, 3 standard. 3 decimal places, yeah? So this is the one special case. So it's a 1.645. All right. Okay, so that will be z equal to 1.645 when the 90% level of confidence or confidence level for z-score. That is z critical value. Make sense? Okay, very good. Hold on 1 second. Stop. All right, so I wrote down the special z critical value, right? Z equal to 1.645 here. And also there is a nice lecture note from the textbook. We have that. Yeah. So please take a look. All right, so rest of them, I'm gonna just show you. So second one, we have 95 confidence interval. How do you find alpha? Alpha equal to 100% minus 95%, that is 5%, right? So we have that here, 5%. Then 5% we can express as a decimal. 0.05, right? Because times 0.01 or divide by 0.01, that means we make 2 decimal places to the left twice, right? So 1, 2. All right. Then alpha over 2 means 0.05 over 2, that is 0.025. Okay, there will be 0.025 will be area of right tail, right? Yeah, okay. Now we're going to normal curve. So we can use the right side, right? So right tail off, or we can use between, either way, that's fine. Yeah, so there will be z-score. We can use just positive because right tail. Yeah, so 1.96. That's the one. So actually alpha over 2, yeah? Yeah, let me make alpha over 2. Alpha over 2. Okay, the third one, we have a 99% confidence interval. So same way, so 100% minus 99%, alpha will be 1%. We convert to the decimal, which is 0.01. That's how they have, right? Okay, then alpha over 2, which is 0.01 over 2, which is 0.005, right? Okay, that will be right tail. All right, so we can use the greater than or equal to or between, right? So we can use that. Yeah. All right, so in that case, they using this one less than, it's okay because symmetric, right? But then we change the in it, the what is called the negative sign, right? So negative sign. So it's we are using only the positive, right? Because of right tail, right? So that is G sub alpha will be 2.576. Yeah. Okay, this is a special z-score too. We're using 3 decimal places. Yeah. Why we are using 3? Because before we are using table by the paper, right? But then their area like a tie. So even. This one is even, this one isn't even. Then we using the middle number of that. That's why we have the 3 decimal places. Okay, now can you please take a picture of that? And you can use at any time when you need this one, right? So we have critical value, Z critical value, and then 99% confident. Then we have Z score, Z sub alpha of 2.576. We just did that, right? So we needed this one. All right. Okay. Now let us do this question. All right, so we want to calculate margin of error. So margin of error, we are using the first letter E, right? E. Okay, so margin of error, which is Z critical value. So that is Z sub alpha over 2 and standard error, right? Standard error. So what is the standard error? So there will be Z sub alpha over 2. Standard error is p hat, 1 minus p hat over n, right? Okay, so let's see. 95 confidence level. Then, what was the Z critical value? 95%. Let's take a look. Oh, right there. So 1.96 highlighted, right? So 1.96. This one we are using it. G sub alpha over 2, right? So G, yeah, 1.96. 1.96 times. This is a time, so let me put the parentheses, otherwise you might get confused. All right, then square root. Inside the square root, p hat, which is 0.325, 1 minus p hat 0.325 over n. How many n? 120. Now we multiply 1.96 and then square root and then everything inside, right? So can you please calculate? 1.0838. Okay, that is margin of error. Very good. So we have p hat plus minus margin of error, right? So in that case, plus then 0.325 plus 0.38 and p hat minus margin of error 0.325 minus 0.838. Yeah, can you please calculate? Yeah, I don't have an answer here. Oh, there you go. We have one. Good. So this is we call the upper limit, lower limit. Yeah. And then other textbook indicate the upper bound, lower bound. Yeah. So we get upper limit, we have a 0.4088 and lower bound 0.2412. Excellent. Okay. So interpretation is based on our sample data. We are 95% confident that true population proportion of students who own laptop is between 0.2412 and 0.4088 or percentage. Yeah. Let me write down for you. Okay, so I wrote down here, we don't know what exact value for the P, population proportion is, but we are 95% confident that the true population proportion of students who own laptop is between 24.1% and 40.9%. Yeah. Okay, so let's take a look. Confidence intervals for population proportions. Okay, so the process is we want to know about what's the p-hat, that's point estimate. And then we need to verify sampling distribution of p-hat is normal. Yeah, that means in order to be normal distribution, the sample size must be big enough. So how do we check? That is n times p times 1 minus p greater than or equal to 10. But in that case, p is not unknown. So it's not unknown, it's unknown. Sorry about that. P is unknown, so we are using p hat. Yeah. So n times p hat times 1 minus p hat must be greater than or equal to 10. So that is a normal distribution. Why? Because we are going to use a StatCrunch normal distribution, right? Yeah. If this is satisfied. Otherwise, we cannot use a StatCrunch normal distribution. All right? Okay, then find the Z critical value, which is Z sub alpha over 2, right? Okay, then we calculate margin of error. Then we can find the lower limit, upper limit. Yeah. Okay. All right. So let us do these questions. So we have study broadband internet access. 279 low income individuals less than 30,000 annual income. 159 had broadband access in their homes. Find 90% confidence interval for the true proportion of low income homes with broadband internet access. Okay, so let's follow the process from above here, right? Okay, so sample proportion. X over N, number of successes, over number of sample size, right? So how many sample size there? Yeah, this is a sample size, good. And yeah. Then how many successes? No, wait a minute. 279 is the sample size we said, right? Yeah, that's correct, right? So 159, yes. Number of successes, yeah? So what do you get? 0.570. And then we need to check whether the make sure p hat follows normal distribution. So n times p hat. So n times p hat 1 minus p hat. Okay, n equal to 279. Can you see? Yeah. All right, so p, which is 0.570 times 1 minus p, which is 0.570. What do you have? It's a 63.3829, which is greater than or equal to 10, right? So it's a normal distribution, right? So all right. Then number 3, we want to know about the Z critical value, right? So 90%, that's why I asked you take a picture, right? So 90%, we get 1.645. So number 3. G sub alpha over 2 is 1.645, 90% confidence interval, right? All right. Then step 4, margin of error. So I need a space, right? So let me make a space here. Margin of error, which is z sub alpha over 2 times square root p hat 1 minus p hat over n. So 1.645 and then square root p hat, which is 0.570, 1 minus 0.57 over n, 279. Yeah. So what do you get? We have 0.0488. All right. Now, last step, right? Lower limit, upper limit. So lower limit. Then we have a conclusion, right? Lower limit, limit. So p hat minus margin of error, p hat, I'm using here 0.57 minus margin of error 0.0488. So what do you have there? We have a 0.5212 and upper limit, so p hat plus margin of error, right? So 0.57 plus 0.0488, we have 0.6188. Now, conclusion, right? So conclusion. So we are 90%, right? So we are 90% confident that the true proportion of, and then we just writing out their sentence, right? So low income individual with broadband, low income home with broadband internet access. It's between the lower limit, upper limit, right? So let me write down. So true proportion of lower income individual with broadband internet access at home is between, okay, so make a percent, so 100%, 2, so 52.12% and 100%, 2, so 61.88%. Yeah, make sense? Okay, now let me show you StatCrunch. All right, so let me take a picture of all the information here. And then I'm gonna input the StatCrunch. All right, so let's go share StatCrunch. Okay, so let me open other one. Open StatCrunch. All right, then uh, go to stack and proportion stacks and one sample with summary. Okay, let me highlight here. Stack, proportion stacks, one sample with a summary. Yeah. Okay. All right. So let's click. All right. Let me erase. Okay. So they ask us, we need to figure out number of successes. Yeah. So that is 159 number of successes and number of observation is 279 and confidence interval 90% level of confidence, right? Okay, then I think that's it. Compute. All right, so let me see the answer. So we have a 52.12% and then 61.88, right? So last two digit little bit different. It might be, yeah, because I was using, we were using by hand, but we round in the processing, right? We could not carry all the digits, right? So we round in the Z-score, Z critical value, right? We round margin of error, we round p hat, right? That's why last two digits might be different. All right? Okay. Let me go back. All right, so let us do this example. What if we have a data set, right? So earlier we were using StatCrunch with summary, right? So in that case, we have data. So we are going to use the data. Okay, let's do it. And let's see, it's vaccinated and 99% confidence level. Yeah. So let us do that. Which one? This one? Yeah, this one. All right. Uh, this is data. Okay. So let me copy and then let's go to the second. All right. So paste. Okay. Go to stack, right? And then summary proportion stacks. Hold on one second. Stack, proportion stacks, one sample with data, right? Okay, let me highlight. Stack, proportion stacks, one sample with data, right? Okay, let me click that. All right, so values in, we are going to using vaccinated. So look, status has all the vaccinated, right? So click that. Okay, then successes. How many successes? Oh, we don't use that number. We are using vaccinated. Vaccine. Let me copy or vaccinated. Okay, then confidence level will be 99 and just compute. Okay, so, oh wow. Hold on one second. What did I make a mistake? Hold on. One more did. Oh, I did not click that. I did not click the confidence level. Hold on 1 second. Let us do one more time. Stack, proportion stacks, one sample with the summary, not with the data, right? Good. Okay, status, success is vaccinated. Let me just copy this one. Yeah, and then paste. All right, so I did not click, right, earlier. It's 99%. Yeah, I don't think I clicked this one. And then compute. Okay, now, yeah, I was not click. Yeah, I didn't click that. Okay, so we have a lower limit, upper limit. Yeah, lower limit, upper limit, and sample proportion, right? Okay, we have a standard data, right? Okay, then let's see. Let me do one more time because I want to show you margin of error. So stack proportion one sample with the data vaccinated, yeah, and then confidence level 99, and then critical value, yeah, can you see that? Critical value, compute. I click that, right? Show critical value, click, compute. Oh, I did not check the status, right? Status. Okay, compute. Okay, so lower limit, upper limit, and standard data, right? Okay, yeah, doesn't fit. All right. Okay, so sample proportion, yeah. So how do you find the margin of error? So we did it by hand earlier, right? But then we can use that. Margin of error is a critical z value, right? Times standard error, right? So if we make times, I have to calculate by myself. So that will be 2.576 times and standard error 0.03868. I want to carry as many I can, right? So that is, I calculate the two numbers. So I have a 0.09963, right? I think that's enough. 996. That's enough. Yeah. Okay. Or we can use that upper limit minus p hat, right? So there will be upper limit, which is 0.76856 minus p hat, which is this is a p hat. So 0.6689. Okay, let me calculate 0.76856 minus 0.6689, right? I get same number, a little bit different at the end. Yeah, it's a 0.009966. But if, yeah, it's the same. If I round 4 decimal places, oh, it's a 7 then. It's a 7. Yeah, because I don't carry all the decimal, that's why. Yeah. So this is a two ways we can use StackCrunch, but there is no direct finding margin of error by StackCrunch. but we can use a little bit of calculation help you from those sequence, right? Yeah, make sense? Okay, let's go back. All right, so let us do sample size, finding sample size. So we have a formula. So how to find the sample size? Oh, okay, so look, we have, let me write down here. So, how about this? So we had what is called margin of error, right? So we had a margin of error equal to what is called the z critical value, right? So z sub alpha over 2 times square root p hat standard error p hat 1 minus p hat over n, right? Okay, so that's why we say that when sample size is bigger, then it leaves the margin of error smaller. When sample size is smaller, margin of error bigger, right? Because this is in the denominator and fraction. Yeah. So this is smaller than whole fraction is bigger. This is bigger than whole fraction is smaller, right? Yeah. Okay. We want to solve for n because of sample size, right? Solve for n. And you see here how? So we need to get rid of this one first. Yeah, z critical value. So divide, right? Z sub alpha over 2 divide z sub alpha over 2, right? So 1 there. So we have e over z sub alpha over 2. And we have a square root p hat 1 minus p hat over n, right? Okay, it's a square root. And then we have n there, right? How do we get rid of square root, right? Square them, both sides, very good. So square them. All right, then we have e squared over z sub alpha over 2 squared, yeah? All right, then we have a right side p hat, 1 minus p hat over n, yeah? Okay, n is here, and then we want to solve for n. So we have two fractions, so we can multiply this way. So I learned from my previous students. They said the butterfly method. Okay, so we multiply this way. Butterfly, butterfly method. Okay. I don't know about the spell. You figure out. I don't have time. Okay, so we have n times e squared, right? Equal to z alpha over 2 squared p hat 1 minus p hat, right? Okay, now e is here. So we divide by e squared both sides. Done, right? Good. So e squared over e squared. So we have n equal to z sub alpha over 2 and same square there. So over e to the second power and p hat 1 minus p. That's how they got it. All right. But then it's a sample size. sample size, always we have a sample size as items or the people, right? So we must be, it's better, more sample, more accuracy, right? So we make always round up. It's not round off. Round off means whether up or down, but then round up means always up. Yeah, to the integer, right? To the whole number. Because more sample size, better, right? Okay. Okay, then let's do this example. So we want to find the sample size of this information. 95% confidence level, and then with an error, that means margin of error, most 3%, right? So that is margin of error. So this is a confidence level, 95%, right? Okay. Look, we don't see any p hat information there, right? Okay, then if we don't have a p hat, use p hat as a 0.5. Unknown. Then p hat equal to 0.5. So let's using that. Okay, so we have a 95% confidence level with 3% of margin of error. We want to find the sample size. Yeah. Okay, then let's notice that what's the Z critical value, right? All right, so 95%. So let's go over all the way. So 95%. Yeah. Does anyone know? So 95%. So we have a 95% here. So Z score, Z critical value. Oh, there we go too. So 1.96. Oops. Okay. So 1.96. And equal to 1.96 over margin of error, 3% means 0.01. So pretend the decimal point here and then move to the decimal point to the left twice. Beyonce method, right? To the left, to the left. Da 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 da, to the left. Do you know the song? All right, so 0.01 and squared. Don't forget square. And p hat is in 0.5 since unknown, right? So we have a 0.5, 1 minus 0.5. Please calculate. Okay, so it's a 1300.07. So always round up. So we can say that 1301 then for the sample size. Yeah. All right. So we want to keep the 30% of margin of error and then 95% of confidence level. Those sample size 1301. Okay. All right. Now we can use StatCrunch too. So let us do this. Oh, there's more. So maybe I can ask you Oh, this is I have to do this one because the P head is given, right? So let us do this and then I'm gonna ask you. No, I'm not, I'm gonna ask you. We do the StatCrunch, yeah? Let me make a little bit orange. Okay, so sorry about that. The number is not right. So this is for the next question. So this number is 1067.1. So we do round up all the time. So 1068, right? All right. Um, we have one more question before go to StatCrunch. All right. So what we have to know, right? So let me copy this one. Oh, yeah, right? It's okay. Okay, so n equal to what's the z critical value when 99%? Please give it to me. 1.96, yeah, 1.96 over this is a margin of error, right? So they said at most error or at most, right? So that is margin of error. It's a percent. That is not the decimal. So we make 0.01. So to the left twice. So that will be 0.035. Yeah. Okay. Now, uh, oh, don't forget to squared. And then p hat, which is 40%, right? So 0.4, that's p hat. So 0.4, 1 minus 0.4, right? 0.035. Okay. What do you get? Yeah, this is the earlier answer. 1300.04. So it will be up all the time. There is up, up, up. Yeah, I'm not good singing. Yeah. Okay. That this one reminds me that K-pop Demon Hunter song. Up, up, up. Well, I'm not good. All right. So anyway, so we round up. So 1,301, right? All right. Okay, StatCrunch now. So let us do StatCrunch. This one, right? 95% confidence interval with a margin of error. Okay. Margin of error is a 3%. We make a double, then we get the 6%, right? Okay. So if we get the 6%, we don't use the 6% there. So we convert to the decimal, that is 0.06, right? Okay, let us do this. This one, right? Stop share. Okay. Let's go to OpenStack and go to stack and proportion stacks, one sample, and then with sample size. So we click that. Let me highlight. Stack, proportion stacks, one sample with sample size. Yeah, click that. All right. Okay, so we had a 95% level of confidence. So let's leave. I did not check that the p-hat. What was the p-hat? P-hat was unknown, so we are using 0.5. Okay, now we have 3% of margin of error, right? So we have 0.03 times 2, then 0.06. Yeah. So we are using the 0.06. Okay, let's compute. So we have 1068. So we don't have to round up in that case because StackCrunch does it for us. So 1068 is the sample size. All right. Okay, so is this the same answer with earlier ones? 1600? Yeah, right. So we do round up. So we had 1067.1. Then we do round up, then 1068, right? And we get the exactly same answer. All right, so this was the last question, and thank you for watching. See you in next video. Thank you. Bye-bye.